All right, guys, this is going to be the first part of the chapter 9 notes, video notes here. Again, just like normal, I'm going to just kind of touch on a few key points in this video, and then in class we'll also talk about some of the the finer details, so you guys can have questions and all that good stuff. So yeah, let's get started here with 9.1 video notes. So here we're looking at whether people who are born in June or July are underrepresented in CEO population. All right, so the first question is, what is the evidence that people born in June or July are underrepresented? So here, when we're looking at this, I'm saying in a sample of 375 corporate CEOs, right, we only found 45, which is just 12%, which is what the problem says, just in the paragraph, were born in June or July. Right now, question is, does this represent an underrepresentation? Well, the question is, well, if you think about it, we would expect around 2 out of 12 to be equally represented, right? If you think about it, June or July make up 2 months out of the year, and we don't really expect that there's going to be any sort of bias in when CEOs are or when CEOs are born. So we kind of expect that 2 out of 12 would be kind of what we expect, and this represents 16% or 16.7%, right? So is this 12%, right? Kind of the idea is this 12% so far away from the 16% that we kind of have reason to believe that if you're born in June or July, you're less likely to become a CEO. Right? That's kind of the idea. So that leads directly to the next question. We just give 2 explanations for why the proportion was below 2/12. So the first explanation is there is no evidence for a disadvantage. I'm going to say the lower percentage was due to chance. So then we say the actual P is still 2 out of 12 or 1/6. Or the other side of this is June and July born people are disadvantaged. And so we say that P is less than 2 out of 12. The outcome found was not due to chance. So then the question is now, how do we determine which one of these 2 explanations it is? So then we say we determine how likely it is to get a sample proportion. This is going to go back to sampling distributions. This small by chance alone, assuming no change or disadvantage. Right, so you can kind of see where this is going. So a lot of you have taken the IB classes. This is kind of going into the null and alternate hypothesis testing. So we will use sampling distributions to test the likelihood of these events or hypotheses. So this can lead into like the big thing that's definitely going to be on the AP exam is significance testing. So what's the difference between the null and alternate hypothesis? So your null hypothesis, and again, some of you probably have seen this before, this is your baseline, or represents no change. So the baseline, the CEO problem, is 2 out of 12, right? 2 months out of the 12 total. So this is what we are testing. Okay. Key thing here, you must use parameters and give both the null and alternate hypothesis. Okay. So in the scenario above, see if we can determine the null and alternate hypothesis. So we're going to say, and we kind of denote this. So your null hypothesis, we write HO or H0. Okay. And because we're looking at percentages, we're going to write P. And then that's going to be equal to our baseline, which is 2/12, right? We expect it to be 2/12. And then our alternate, we can write HA. Some people write H1. Doesn't matter, whichever you like. Okay. And then here we're saying that we believe that people in June or July are disadvantaged based on our sample that we got. So I'm going to say P is going to be less than 2/12. Okay. And again, this is because when we looked at our first problem, we said that we only noticed that 12% were born compared to the 16%. So we're like, well, maybe being born in June or July is going to be a disadvantage. So we're going to say this. And so here I can just write, since you believe that there is a disadvantage, you will use less than, right? But again, that's all based on the problem. So, maybe you think that June or July is going to be more likely. So then you have greater than. Maybe you're not sure. Then you're going to use the not equal to sign. We'll kind of get into all those later. Okay, so read the next problem, part B. See if you can kind of figure out what the null alternate hypothesis is here. Again, it all depends on what you're testing, right? So in the one above, we were testing proportions. Here, we might be testing something else. So take a look at that. So what's the difference between a one-sided and two-sided test? So hypotheses are formed before collecting data. So use the question to guide the test, which is what I did on the first page. Look for keywords, right? So such as if you have like changed, / different, indicate two-sided. So not equal to sign. And all this is going to do is going to impact when you look up your p-value. So again, we're going to go through a lot of conditions. We might check. We're going to check normality. Once we get to the z-score, are we going to use one tail? Are we going to use two sides? So it's going to change all that stuff. So p-value, we've talked about this before. A p-value is the probability of getting evidence for HA as strong or stronger than the observed evidence when the null is true. Okay, so kind of what does that actually mean? So let's say we get the p-value is 0.008, interpret this value. So I'm going to say something like, assuming that the birthdays of CEOs is normally distributed, there is a 0.008 probability of getting sample proportion as small or smaller than 2 out of 12 by chance alone. All right. So see if you can kind of figure out the two scenarios here, or the two options you have, and then see if you can, and then we give you a p-value, see if you can kind of interpret what I just wrote here in this problem. Again, we'll look at it in detail. Last thing I want to do for this page is kind of draw some pictures. So one-sided test. So here's your distribution. So if this is a one-sided test, I'm going to look at this. This is your p-value. So this line here is your p-value. These are all one-sided. You can also do the other side, right, as a one-sided test. So here's your p-value. And there's parts that I'm shading on called significance regions. This is the part where you're going to reject the null hypothesis, which we're going to talk about in more detail as we go along. And two-sided, this is one. You can kind of probably see what I'm going to do here. You have one cutoff value and another cutoff value, and then you have two significance regions over here and over here in the corner. Okay. And the difference here between, we have this alpha level we've talked about before. We talked about alpha being 0.05. When you have a two-sided test, you just cut it in half, right? Because you're going to have half on one side, half on the other, because these are symmetrical distributions. So those are some pictures to kind of help you see that. All right, so now moving on, what are two possible conclusions for a significance test? So here, what I want you to do is just think about criminal trials. All right, so here we are innocent until proven guilty. So we have preliminary versus convincing evidence. And then if the p-value, this is kind of leading to what we're going to talk about, is extreme, what we're going to say is we're going to reject HO, meaning that we have evidence that HA is true, which also means that this is not likely to happen by chance. On the flip side, if p-value is large, then you fail to reject. This is going to be the key here. We're never actually accept anything. We reject and we fail to reject. And so then we have no convincing evidence that HA is true. Okay. And if you think about this back to our pictures, right? If I have a large p-value, right, that means I'm going to be somewhere in the middle over here, right? Small values are going to be in the extremes. So if I have something like this, right, it's going to be a large p-value. Well, this is pretty likely to happen, right? So we're not going to have evidence against our hypotheses. So our two conclusions that we can kind of draw, right, kind of just to bring this onto like a small little thing, is you can either reject HO or you fail to reject HO. And then the reasons being the ones that I just talked about. Right, but again, you notice that I never say accept HA. Okay, I never say I accept HO, right? It's all just reject and fail to reject. And that leads directly into the next point. What are some common mistakes that students make? Number one, no context. We've talked about this a lot already, right? You got to talk about it in the context of the problem. You will lose points in the AP exam if you don't. Number two, accepting the null. If we fail to reject, we are saying that the HO value is one of the plausible values for the parameter. Think back to our confidence intervals. Number three, make sure you talk about the p-value. Your p-value is your evidence. So you got to link your p-value to your hypotheses, and that's what it's going to be in order to get full credit. Okay, so what's significance level? So here, so be careful with the word significant. Significance level, which is what we call typically alpha. Is the boundary between quote unquote small p-values and large p-values. Okay. It is the cutoff for fail to reject and reject. Okay. So, and then one last picture that's probably pretty helpful. You have this distribution. All right. You have your alpha here. Alpha. This is your level of significance. Level of significance. Okay. And here, this pink region in here, this is your rejection region. Okay, because again, extreme, think about extreme, then you have evidence against your null hypothesis. So here you reject. And then here in the blue in the middle part, shade this in, this is where you fail to reject. Right? This is likely to happen. Fail to reject. So again, we're looking for extreme p-values as evidence. So read this last problem on your own. See if you can kind of determine your conclusions based on two different p-values. We'll go over that in class together. And that, actually, we'll keep going here in this video. I'll kind of finish up all of 9.1. So last thing about 9.1 is kind of just a quick little overview. Is what kind of mistakes could you make when looking in significance testing? So if you think back to a criminal trial or jury trial again, right, you could either wrongly convict or you release someone who is guilty. Okay, and I want you to think about this, right? Which one is worse to do? Right? What if we require 10,000 eyewitnesses to convict, right? What would happen then? So why don't you think about that? And so that leads into the types of errors that we can find. So we have two different types of errors that we're going to talk about, type 1 and type 2. So type 1 is finding convincing evidence that HA is true when it really is not. So this is a false positive. And then we have type 2, which is the opposite, which is not finding convincing evidence that HA is true when it really is. Right? And this is a false negative. Okay. So I want you to see if you can kind of think about the type 1 and type 2 errors in the CEO problem. And again, we'll go over that in class. And I'm just going to draw you a little picture that might help. Kind of break this down a little bit. So this little table will help you kind of remember all these. So let's label all this. So if you fail to reject the null hypothesis and the null hypothesis is true, this is going to be accurate, so we're good here. Okay. Going down, if you fail to reject the null hypothesis when the alternate is true, this is a type 1. Okay. Likewise, I'm going to kind of go around in a circle here. So now if I reject HO and HA is true, this is correct, so we're good. This is accurate, so we're good here. And the last one, if I reject HO when in fact HO is true, this is a type 2. Right? This is your false negative. So this shortcut, maybe we can kind of break things down for you a little bit. See how it goes. Okay, what's the probability of making a type 1 error, and what's the probability of making a type 2 error? So last big thing here in this video. So type 1 errors, we find convincing evidence for HA when P hat is the leftmost 5% of the curve, right? That's our cutoff value. So then, but how often will P hat be out there by chance alone? Right, that's 5%. And so the probability of finding convincing evidence for HA, given that HO is true, is equal to 0.05, which is also equal to alpha. So your significance level is your alpha. Okay, so to reduce it, we do have to demand that the evidence be very convincing before rejecting HO. So that implies that we could have smaller significance, like a 0.01, which leads to a greater chance of a type 2 error. So there's a little trade-off here. Right, so less false positives means more false negatives. There's a little trade-off between those two things. And the last thing I want to talk about real quick, the likelihood of finding a type 2 error. This is called beta. And this is really hard to find. So it will be either given, or you will not be asked to get, or you will not be asked to calculate it. So we don't worry about type 2 error, we just worry about type 1. Okay, so that's it. That's all of the 9.1 video notes. As always, you guys have questions, please let me know, and we'll go through some of the examples together in class. All right, have a good one.